I hope you all guys can see my screen.
Yes.
Yes.
Okay, great. Give me another minute. Someone drew something on the screen. Um, Not sure who that was. Okay, so let's quickly recap what we have seen yesterday, and then we will go through um, today's session. So yesterday we did started with basics of where exactly FHIR gets started. We spoke about hospital workflow, and we understood the data flow from one application to another application. And that brought us to a point where we understood that entire hospital data is stored in the EHR for a certain patient. And there is data coming in and being exchanged with the application that is used by receptionist. It is the app that is used by providers, app that is used by labs, pharmacies, and so on. But unfortunately, patient who is center of the cycle doesn't have access to the patient details himself once he is outside the hospital. So that's where FHIR comes as a solution, where you add a FHIR layer on top of your existing EHR database, and that helps FHIR data or hospital data to be exposed to the outside world. And then the outside entities like mobile apps or desktop applications can interact with FHIR resources and exchange data with the EHR database. So that's what we have seen yesterday as the solution. So this is called as FHIR facade layer. Facade usually represent adding a face. So as we are adding an external face uh, to the EHR database or EHR application altogether, this is called as FHIR facade layer. Similarly, you also have a FHIR repository layer solution. In case of a FHIR repository layer solution, the entire hospital data is converted into a FHIR database, meaning all the data is stored in the format of FHIR itself. It could be JSON, XML, or Turtle. More predominantly, we see JSON being used in the industry, but it can be any one of these three FHIR formats. And data is natively stored in this format, and that is exchanged with the external world through the FHIR layer again. So now the patient can have access to his own data through an external entity like mobile application or desktop applications or a website if needed, right? So what is FHIR? We understood that there are many standards. There is increasing demand and requirement of exchanging data, and the current standards did not help with such sufficient scope. That's where FHIR has come into play. And we understood that we have to use latest technologies in order to um, leverage the new, I would say, new advantages that we have with the latest technologies and all. That's where FHIR has been created around REST APIs, which is the which is the new methodology at that point of time. And then we spoke about evolution of HL7 standards. So it all started in 1997, and then FHIR got started in 2010, and a benchmark standard, which is a normative standard of FHIR, has been released in 2019, which is FHIR R4. We also spoke about four paradigms of FHIR. We have REST APIs, we have documents, we have messaging, and we have services. So in today's session, we will talk a little bit more about resources because FHIR stands for Fast Healthcare Interoperability Resources, and we understood first three terms. The last term is resources, around which the entire specification is based on. Everything in FHIR is expressed in the form of resources. So let us first understand what is a resource, right? So a resource is basic building block in of FHIR standard. So what we have here, any smallest amount of data set that makes some meaningful information is called as a resource. For example, patient registration data. Let's say patient is getting registered. His basic information with patient demographic detail like first name, last name, date of birth, gender, patient identifiers like SSN or passport number, and his address and his phone number. These basic details together become one uh, one small unit, and that small unit of data set is called as a resource. In this way, there are many different data sets uh, in the hospital environment or hospital clinical ecosystem. Now we are talking, I gave you an example just about patient. Let's say once the patient is getting registered, they will also have, they will be given certain forms just to fill it up so that they can enter the data into the EHR system or PM system, right? First, they will get one form which where they fill up their demographic details. There will be second form where they will create or fill up their guarantor related details. Then there will be a third form which will be used for insurance related details. So let us assume that a patient has been handed over with three different forms, right? And patient is filling up those forms one by one. First form, patient demographics. Second form, guarantor details. Third form is for insurance information. Each form can be considered as a resource because each form has confined set of data points, and these data sets, each one of them is called as a resource. Okay, so each resource basically represents highly focused data, smallest unit of data set, and which also makes some meaningful information. Okay, so the entire FHIR specification, where it represents the hospital data in the form of resources, can be considered as a template. So you will have one resource for allergies, one resource for prescriptions, one resource for referrals, one for medication, one for appointment, one for schedule, one for encounter. So there will be hundreds of resources that will be there, which will help us to represent the entire data that is present in the clinical ecosystem in the form of small data sets called resources. All right. And when we talk about these forms, one single resource might not give you full picture of what it is all about. For example, if we talk about the registration scenario itself, if you, let's say someone plays the insurance form, and if we take a look at the insurance form, we will understand that okay, this is an insurance data. We will also get a picture what insurance it is, what is the insurance phone number, what are the insurance details. But if it is not tied, if that form is not tied up with the patient form, then we wouldn't get to know which patient that particular insurance details belong to, right? So if you combine that together, that's when you will get a full picture that okay, this is the patient details, these are the patient details, and this is the insurance form for that specific patient, right? So in order to see or view one clinical record, you would need to combine multiple resources together and have a full picture of what that clinical record is all about. By looking at one single resource, you can make some meaningful sense out of it, but it doesn't give you a complete picture of what that is all about, right? So, single resource may not tell you much, but collection of resources will give you a full workflow picture or full functional picture of what data we are talking about, right? So let's talk about the resource. So as I said, we will just take a quick look at an example of patient resource which has minimal data set. So when we talk about patient details, what do we get to see in mind? We will get to talk about patient name, patient identifiers like passport number or SSN number or something else, and then you have patient's telephone number, patient's marital status, date of birth, address, and so on. Now, these are details that are usually captured while registering a patient details into the PM system, right? And once that is done, how it is stored in the form of a FHIR object. So if you take a look at the FHIR structure, this is a vague structure. You don't, I mean, vague in the sense, this is the structure from FHIR specification page. We will go in detail about this structure in later videos. or later sessions. But for now, let's take a look at what is being represented here. So here you can see that we have identifier. We have all the various elements like name, telecom, gender, birth date. Then we have address and marital status information, right? Again, these identifiers will have multiple child elements. We'll talk about child elements once we understand more about the JSON structure. But at a high level, every element may be, not always, but may be divided into multiple child elements if needed, so that the granular data of patient details can be captured. For example, if we talk about name, within name we have first name, last name, then we have prefix, suffix, and then we might have multiple names like nickname and an official name and so on, right? To support all of them, every element or few of the elements may be broken down into multiple child elements if needed. Okay, and then you have marital status here, which is representing the actual marital status of the patient. In this way, you will have a resource structure laid out within FHIR specification. Okay, you will have patient details. These are the basic details that we capture. This is the systematic structure that is represented in the FHIR standard to capture patient details. This structure that you're seeing is for a visual representation, but when we talk about the actual technical JSON format or XML format, we will understand it in a little bit better manner of how this data is broken down, how elements are broken down, and how we can have that systematic view or format of the data that we are going to store. Now, let us take a look at or let us understand the JSON structure first. What is JSON? And we will try to see um, what are the things that will be or how to read a JSON object. This might be new for people who are working with HL7 V2 and planning to move to FHIR, and for freshers also this is very much needed, because without understanding the JSON structure or how it is built, it is very difficult for us to follow through the entire training or understand anything going forward, right? So the format, the data we are going to store in is very, very important. So let's open Notepad. Are you guys able to see my Notepad screen?
No,
No.
Okay,
not
give
yet.
me a second. Can you guys see it now?
Good, good.
Yeah. Yeah.
Okay, perfect. All right, let us talk about JSON. What is JSON? JSON stands for JavaScript Object Notation. All right, and this is the native data format for JavaScript. So when JavaScript was being developed, in order to sorry, in order to oh, sorry about that. So in order to go ahead and exchange the data in the through using JavaScript, there has been a development of an object called as JSON. So this is a native object in which JavaScript can operate and exchange the data with external systems. So let's say the main content comes from the fact that JavaScript is mainly used for the browsers to interact with a server. You are going to Google, you are typing Google, or you are typing something in Google search, right? Behind the scenes, data exchange or the website is made interactive through JavaScript. Okay, and the data exchange happens in the form of JSON objects. So that JSON object itself is the primary, or I mean, that is not the only format. In our training, we will go through usage of JSON, but you also have XML and Turtle, which are supported by FHIR. But our main focus will be on JSON itself. And when browsers had to exchange the data, that is being exchanged in the form of JSON, and REST API uses JSON as one of the lightweight object to exchange the data. So how is a JSON object created? So this is a valid JSON object. A JSON object is always enclosed in flower braces. Okay, and then within a JSON object, you will have key and value pairs. Key and value pairs. So the data will have the name of the data point and its actual value in real time. For example, let's say we are talking about patient details, right? I'll say patient details as name of the patient, and then we'll have the name of the patient as Dixon, right? Let me set the language to JSON. Okay, and then we have date of birth of the patient, right? So this is the date of birth of the patient, and then you have phone number of the patient. This is not the actual JSON structure that is used in the FHIR object. This is just for us to understand a generic JSON format. Once we understand how a JSON object is built, then later we will go ahead and take a look at detailed structure of how the format of data or format of JSON is for FHIR resources. This is just for our basic understanding of what JSON is. So phone number. Okay, now you can see that this is one JSON object which is expressing the data for a patient, his name, his date of birth, and his gender. And his phone number. You can see that it's a combination of key and value pairs. So there will be a data element. You can call this as an element which will present or which will have a key which is representing the data point, and then a value which is actually telling you the real-time value. Now, one element is separated from the other with the help of comma. So this is mandatory. Last element obviously will not have a comma because there is no uh, element after that. So you can just leave it for the last element, and they are enclosed in a flower brace within flower braces. Okay, this is a basic JSON object that we can create in real time. Now, when we talk about assigning values to individual elements, this is element number 1 in line number 7, element number 2, element number 3. And I mentioned that we have key and value pairs, right? These values that you are assigning within a JSON object can be of different kinds. Okay. Now, let us say I want to also add what cars Dixon has. Okay. Let's say I have multiple cars. How do I represent that? How do I indicate that within this particular JSON object? I can do two things. One, I can say car 1 as Honda, and then I can also say car 2 Toyota. That's all. So I have two cars. So I am representing two cars here, one each with each element. All right. But is this a very effective way of storing the data? Very effective way of storing the information. Let's say I want to grab or I want to extract information related to all cars that Dixon has. Is this the proper way of storing the information? We can extract, not a problem, but that's not an effective way of extracting that information, and this is not the effective way of storing data which falls under similar category. Okay, cars can be, here all cars will fall under one single category like vehicle, right? So instead of storing the data in multiple elements, what you can do is you can create only one single element, and you can create an array. Array is represented with the help of square brackets, and within an array you can store multiple elements of same kind. So you can represent Honda, then you can represent Toyota, and if you have much more, then you can go ahead and add as many number of values as you want within that array. Okay, so we do not need a comma at the end for the last element, as I mentioned earlier. So here now we have looked at first type of assignment or first type of value that can be assigned to an element is regular value, a value with single description. You can add a value as name or anything. You can add a number, as you can see here, and then you can have a second type of assignment, which is nothing but an array. An array can go ahead and store multiple values of same kind. Okay, you can store as many number of values as you want. There is no limitation on that. All right. So this is second type of assignment. Now third type of assignment. When we talk about name, we I just gave the name directly as my name, but my name might have multiple components like first name, last name, maybe a suffix or a prefix. Let's say Dr. Dixon Jr. We have suffix and prefix here, right? So I can go ahead and have the name represented here itself as Dr. Dixon Jr., but I would prefer not to do that. I want to be granular and I want to have clear representation on what is given name or what is family name or what is last name in a clear manner. Nothing wrong with storing the data in this format, but it will not give a granular picture on what is given name from this, what is last name, what is prefix, what is suffix, right? So the user who looks at this data will have to make out and understand that, okay, this could be the first name or this could be the last name, but that might not be always right. He is taking that from his perception or his assumption perspective, right? So we want to have clear data structure or clear indication on what is first name, what is last name, what is prefix and what is suffix. So that's where the second type of assignment comes, third type of assignment comes into play, which is nothing but assigning another JSON object to the element itself. Okay, so you can also not only assign a certain value, you can assign an array, you can also assign another JSON object altogether. So here, let's add a JSON object. As I said, JSON objects are always enclosed in flower braces. So we have added a JSON object. Let's add elements within that JSON object. So I will say first name, that would be Dixon. And then I would say last name, and then I would say prefix, right? We can also add suffix as well. Okay, so now we can see that we have added another JSON object altogether or assigned another JSON object altogether to an element called name. So when we have this kind of structure, this is called as parent element and these are called as child elements. Okay, you can have multiple children elements within one single JSON object. Okay, so now this becomes the first level of object or first level of element within this JSON object. Then this becomes the second level of elements within this JSON object. Okay, now what if I have multiple names? We have scenarios of using nicknames. Few of them will be called, though they have official names, they will be called with nicknames. Few of them might be having uh, a scenario where name being changed after marriage, right? And both the names should be represented within the JSON object that we are creating. So how can we do that, or how can we use that particular scenario where we represent multiple names within the name element? Okay, This is where the next part of the assignment comes into play, which is nothing but adding multiple objects within an array. You can do that as well, right? So let's go ahead and do that. So here we have simple JSON structure. Now let's enhance that. What you can do is you can create an array for name. We know that we can assign an array, right? From the previous examples of car, we understood that we can assign an array, and array can have multiple string values, as you can see here, Honda, Toyota, and so on. Not only that, in case if you have multiple JSON objects that you want to put into one single element, you can do that by creating an array. Within the array, you will add multiple JSON objects like this. Okay, so let's do that. So this is our array that we have created, and within that you have JSON object number 1. Then you have second JSON object where I would say that okay, there's official name called John or a nickname called John, and then we don't need other details like prefix, suffix, and so on, because that's a nickname, right? So when we talk about JSON object, you can have a simple JSON object like this. Each line or each element comprises of a key and a value. This value can be of multiple kinds. What we have seen here is a string value, which is a direct word or a string that is assigned to this particular element name. And then you can have multiple values within that particular element also if you want to, and that's where you will have an array created. And if you have a situation where you have to create multiple child elements, you can do it this way by creating another JSON object and assigning that to the element. This is the third point. And then the fourth point is we can have multiple objects as well for single element by creating an array and then adding all the objects within that array. Okay, so this is what the JSON structure looks like. So before we move on, anyone has any questions with respect to JSON structure? Because understanding this is very, very important. Without having understanding of JSON object, we cannot proceed with understanding the patient resource structure.
Hello.
Hello.
Hey, hi, this is Walker here.
Hey Abu.
Can you explain the fourth one once again?
Sure. So the fourth one that we are talking about is multiple objects within one single element, right? So we understood that with respect to cars example, we can insert or put multiple values of strings into an array. But in case if we have to put JSON objects as well, you can do that simply by inserting the JSON objects directly into that array. And this is a very common scenario. You will have a situation where you may want to represent multiple names, or let's say, let's add another element, right, called a address of the patient, right? Patient might have one temporary address and one permanent address. So if you want to add these two, then you can create an array, and within that array you can start creating the JSON objects, each JSON object representing one kind of address. Let's say I will just add one element called address type. I'll say this as permanent address. Okay, and then we'll just give the actual address some x. Okay, so we have created one object. The purpose of array itself says that there could be multiple objects of same kind or multiple elements of same kind or multiple values of same kind, not elements but multiple values of same kind, right? So here As it is an array, you can have multiple objects inserted or stored within this particular array. So you can add another address type, another object, and call it as temporary. Right? In this way, you can have as many number of objects as you want. And determination of how many objects and all, we'll see that later once we start with the actual actual understanding of JSON objects and so on within FHIR. But the idea is that you can have multiple objects if needed within one single array. Okay, does that make sense, Abu?
Yes.
Okay. All right. Any other questions from anyone?
Hey, Dixon,
Hey, Prince.
for the address part, where you have address, so I guess that's the street address, and then you're gonna add another object after that, called maybe state, and then after state, you might add another object called city. Is that correct?
Right, right.
But it
Within
won't
the
be
no, no, within the
within,
object,
right,
right. You can have multiple elements. One is city, state, country, and so on. Zip
right,
code and so on.
right. Hey, can you go to the very top again?
Sure. Mm-hmm.
Okay, when you all the way, I think before you start the key value, I think that was
Mm-hmm.
right. So you have the curly brace before the key. Is that a normal way to start?
Yeah, I mean, JSON objects are enclosed within curly braces. That's what I wanted to represent by adding curly braces here.
Correct. So that code doesn't mean anything then, in that case. Is that correct?
No,
Where
no,
you
no.
have the curly braces and then the key value.
Right.
So
This is
those,
a valid JSON object.
got you. So that's more like a note, is that right? How do you, if you want to add a note, a comment, would that be represented this way or no?
It will be represented this way.
Okay, got you.
Sorry.
Hi, Dixon. So in the normal way, like
Mhm.
whether the patient details will be stored in one JSON or it will be in multiple, like for each member, one object will be created, or for multiple members, name multiple, under the array, multiple patient details will be captured.
No, no. Every patient will have their own JSON object in FHIR. I mean, I understood your point that we create one object and have multiple names, multiple addresses for patients, but that's not how it is stored. Within the JSON, within FHIR objects, every patient will have their own dedicated JSON object, and that becomes their identity. I mean, technical identity with respect to the database.
Sure. Thank you.
No problem. We'll see that once
This,
we start looking at the JSON structure, patient resource, you will get a clear picture. Yeah, Prince,
this
go ahead.
guy, I think I get it, but for where the patient has like an alias, where the patient has a nickname,
Mm-hmm.
and then for those elements, you added just the first name, John, I
Correct.
believe.
Right.
So if I am, so how wouldn't that be a problem? How would you structure it? Say in the case you want to extract this patient's
Mm-hmm. Mm-hmm.
name as well as the alias to
Mm-hmm.
an HSV2.
Mm-hmm.
How how would you structure that?
We will
To
see that. This is just understanding of the JSON formatting, JSON structure, what you can assign as values, what kind of
yeah,
values can be assigned. But once
gotcha.
we start looking at the actual FHIR object, we will get into details of how can you determine how many objects can be created within an array. How can you
Gotcha.
determine which element is required, which is not? How can you differentiate between two objects? We will see all of those things. Those are coming up once we get into the details of patient resource. You will get a clear picture.
Great. Thank you.
No problem. Hey, Harris, do you have a question?
I probably do, but just I came in late, I'm not sure if it's the first or second class, but my question really was JSON, is JSON the only script for FHIR, or is there another script language that's is needed?
JSON is the object format that is predominantly used, but
Okay.
FHIR also supports XML. You can very well use XML. It is also one of the most frequently used formats after JSON. And then you also have something called as Turtle, but usage of Turtle is a little less than compared to JSON and XML. So if you see the hierarchy, JSON will be at the top, and then you will see XML, and then Turtle is very less in real-time usage. We have three formats that is supported. Okay. Hey, Prashant, Prashant or
Yes,
Prasad?
Prasad, I
Hey,
think so.
Prasad. Sorry.
Yeah, yeah. I just want to check. So how we can practice? Is that if we can use a notepad to write the script to just want to ensure that whether we are writing the right one, or if in case of incorrects, how can we practice, or
We,
how
we,
can we figure it out?
mhm. Yes, we will go ahead and take a look at once we understand the patient resource structure. I'll give you an assignment. I will also show you how to use VS Code, which will act as a validator to tell you if you are making mistake anywhere with respect to the structure as well. So we will see that, but I would still prefer using plain notepad to create a proper JSON structure. Once we create the JSON structure, we are going to post it to a HappyFire server, and that will tell us whether your object structure is correct or wrong. If you make mistake anywhere, it will automatically tell you what all errors are present within your JSON object. So that's the best way.
Okay. Hey, thanks, Alex.
No problem. Any other questions from anyone else? Okay, now let us go ahead and navigate through the FHIR resource, patient resource structure. I will just start with it and we'll continue tomorrow. Okay, so I'll just take you to the specification page. Let me go ahead and share my browser window. All right, so if you would like to go to the FHIR specification page, you can just go to, just type FHIR R4. That should be more than enough. You can just click on R4 specification page. Our training will be driven based on R4 itself, though we have R5, R6 coming up. They are not normative standards. We will talk about what normative is in the upcoming sessions, but there is reason why we are sticking to R4, and we will be covering a lot of aspects from R4 perspective itself. So the moment you go to the main page, the moment you go to the main specification page here, you can see that you are in the home page where you have details on uh, level 1 basic understanding, then what resources you have to go through, then it talks about administrative resources. But going through this route is little quite difficult because this gives you a high level overview of what topics you have to cover through. But if you start going through each one of these, it will take a lot of time, and especially with level 2 aspects, which is talking about security, consent, provenance, all of these things cannot be understood well until you understand the object structure, or how to read a JSON structure, or how to read a patient resource, or how to read any resource in fact, right? So we will not be starting with home. We will first begin with a section called resources. So within resources, you have all the resources that are used. So by now we understood that a resource is smallest unit of data set, which represents highly focused data, right? So that's what a resource is all about. Now, in that way, entire hospital data is divided into multiple resources. And these multiple resources can be for patient, practitioner, which is nothing but doctor. Then you have organization details. There are many more other resources as well, right? So when you come to this resources section, this is where you will see all the resources here represented. And there are various views. You have category view, you have alphabetical view, then you have maturity, then you have security, and so on. It's up to you which one is which one would you prefer. I prefer categorized view because that will tie up the resources to a functional understanding or functional aspect of how where that particular resource is used, right? So we will start with the base section where we talk about the patient resource as the first resource, right? You can click on this patient resource and it will take you to a new page. Here you will have full details about the patient. Okay, so what all details we have? We have scope, we have usage, then you have section for resource content. This is where entire patient resource structure is represented. So we will go through this detailed section in tomorrow's session. We will start with patient. We'll talk about few elements. We'll talk what these columns are, why they are used. We'll talk about this description and constraints also. And then we'll talk about page layout, what is represented in each resource page, so that you can get a clear picture on what template is used for all resources. This is a common template for all resources, and this will help us to understand or have a perspective on how we have to understand each resource. Even if you have to go through any resource in future, you will have that picture on what template is used for each resource within FHIR specification. Okay, so we will start this tomorrow. And now that we have understood the JSON object, tomorrow we will go through the patient resource and create our first patient resource and see if we can post it to HappyFire. All right. So any other questions from anyone?
Can you share the notepad or no? The one, the codes, the JSON that you have in notepad, or
I will
it's
share it.
just
I'll
okay.
I'll share that. I'll save that to our Google Drive, and you can access it from Google Drive.
Great.
Okay. All right. So let's go ahead and conclude today's session here. Srinivas has shared his details in the chat. If you would like to enroll in the training and continue with the sessions, you can do that. Tomorrow's session is also demo, so please feel free to join if you would still like to join, and after that you can make a decision. We will start to have continual sessions from next week. Tomorrow's will be the last session for demo in this week, and from next week we will continue to have the regular batch. Okay, so feel free to join tomorrow as well. Srinivas, if you would like to enroll, then please contact Srinivas through his number.
So for the regular batch, the time will still be the same, right? Is that right?
Yes, as of now, the time will remain same. In case if there are any changes, I will let you know.
Okay.
Okay, great. All right. Thank you, everybody. You all have a great rest of your day or rest of your evening. We'll catch up tomorrow. Thanks, everybody.
Thank you.
Thank you.
Thank you.
Thank you. Thank you, everyone.